we're going to recap inverse functions, which of course we looked at. So back in term 1 we did inverse functions? I think it was. So let's just have a quick recap. So if there exists a one-to-one relationship between the two sets of numbers, the x and the y values, then both the relation and the inverse relation are functions, is what we're basically saying. In that case, the inverse relation becomes the inverse function. Now remember, a function will either be one-to-one or many-to-one. I mean, the many-to-many and the, hang on, what's the other one I haven't said? And the one-to-many were both relations. But functions could be either one-to-one or many-to-one. Now, the one-to-one's fine. Its inverse relation will be an inverse function. But the many-to-one won't be. We'll talk about that in a sec. So if we've got the one-to-one, then we know if we substitute in the inverse into the function or the function into the inverse, doesn't matter which way around you go, you should simply end up with x. And how do you test whether it's true? Well, you can use a horizontal line test. We used a vertical line test for functions. Use the horizontal line test, will tell us if it has an inverse function. If you don't have the picture, or you don't know what it looks like, then you can play around with the algebra, swap the x and the y's around, then try and make y the subject. And if you get something that's unique, then you know you're fine. But if you find yourself saying plus or minus or something like that, then you know it's no good. Now, here's an interesting fact. I don't know whether I mentioned this last time or not. The inverse function of an odd function will also always be an odd function. However, even functions won't have inverse functions. And that's because of line symmetry. Well, if it's got line symmetry, it's going to fail the horizontal line test every time. Okay, domain and range. If AB is on the function, then we know BA will be on the inverse. So the domain and range basically swap around. The domain of the function becomes the range of the inverse, and the range of the function becomes the domain of the inverse. Here's a simple example. Our exponential y equals e to the power of x, which looks something like that. Its domain's all real x, its range is y is greater than 0. Swap the x and the y's around. Let's find our inverse. So x is equal to e to the power of y. We want to make y the subject. We have to do the inverse function, which is log for an exponential. So we get y equals log of x. The domain will become x is greater than 0, because the range of the original one was y is greater than 0. And the range becomes all real y, because the domain of the original one was all real x. And if we graph it, we should find that it's a reflection in the line y equals x. So there's our log curve. However, we said one-to-one's fine. But if it's not one-to-one, and let's face it, most functions aren't, then we need to restrict the domain. We just want to get a piece of the function that we can then go and invert and use. So we want to turn it into a one-to-one. Now basically you want to get a section of the graph which is continually increasing or continually decreasing. In other words, it never turns around and comes back up and thus fails the horizontal line test. So let's do the classic one, y equals x squared, which clearly fails the horizontal line test. So its domain at this stage is all real x and the range is y is greater than or equal to 0, but it won't have an inverse. Well, we want to create an inverse. So if I restrict the domain, now there's two choices I've got here. So I want a piece that's either continually increasing or continually decreasing. I could have chose x is less than 0. I went with x is greater than 0, or greater than or equal to for that matter. I guess as a general rule, we try to include 0 if we can. So I've done that. Tend to go with the positives rather than the negatives if we can. But it's not a rule as such, but that's just generally what we do. So I've gone with x is greater than or equal to 0. The range is maintained. I still get the complete range by doing that with this function. So what do we end up with? We end up with x to the power of a half, or positive square root of x if you like. And if we draw it, there it is. It's basically the top half of the parabola. If I had chosen the other one, then I would have ended up with negative the square root of x. So they're both possible answers for it. Let's have a look at an HSC one. a few years ago now, 2010, they had the classic bell-shaped curve, e to the power of minus x squared. So there's the graph we've been given. Now, this first part, I mean, technically we haven't looked at inflection points and things like this. So just bear with me on the first one, but I need to solve this so we can look at this question, the rest of what it asks. So the first part that year they asked, what are the x coordinates of the points of inflection? What we do know is that possible inflection points will occur when the second derivative is equal to 0. So I need to differentiate my exponential a couple of times. So e to the minus x squared goes to minus 2x e to the minus x squared. Do it a second time, but I've got to use a product rule. Write down the first, diff the second, plus write down the second, diff the first. And we end up with 4x squared minus 2 outside e to the minus x squared. Solve that equaling 0. Now, the thing is, when we're doing inflection points, they're only possibilities. Normally, I would go and check and test whether they are actually inflection points. Don't need to for this one, because they told me it has 2 points of inflection. I ended up with 2 possible answers. Therefore, they must be the points of inflection. I don't actually have to go and check. They asked for the x coordinates, so I don't need to worry about finding the y values. X is plus or minus 1 on root 2. Okay. Oh, you love these sorts of questions where you have to explain. Explain why the domain of function x must be restricted if function x is to have an inverse function. So what are they getting at? I mean, I wrote something like this. In order to have an inverse function, there must be a one-to-one relationship. In other words, every value in the domain gives a unique value in the range. That sort of thing they're looking for. I mean, I guess you could write, it has to satisfy the horizontal line test. I mean, there's all different ways you could explain why you need to restrict it. So part C, find a formula for inverse function of x if the domain of function x is restricted to, so they've told us how we're going to restrict it, x is greater than or equal to 0. So again, they've gone with the positives, they've tried to include 0. Okay, we have to swap the x and the y's around. So x is e to the minus y squared. We now have to make y the subject of all this. So log both sides, minus y squared is log x. So y squared is minus log x. But I don't want to know what y squared is, I want to know what y is. Hang on a sec. Y squared's negative? Well, that's all right. Negative log x doesn't mean it's a positive number or a negative number. It all depends on the value of x, doesn't it? So minus log x, I'll bring that negative sign into the log using my log laws. It's now positive log. But it's the log of 1 on x. So that's fine. You can find the square root of that. But I would get plus or minus the square root. We've restricted it. We have to decide, have we got the positive square root or the negative square root? But we have restricted the domain of the original function to be x is greater than or equal to 0. And we know the domain of the original function becomes the range of the inverse function. So therefore, the answers for mine have to be positive numbers. Therefore, I must take the positive square root for this. So the positive square root of log of 1 on x. What's important here is the explaining on why you're doing things. If I hadn't put that explanation in, because remember they said, find a formula for it. And the question would be, well, hang on, whoa, you got plus or minus? Why did you get rid of the negative? What did you do that for? So you explain what you did. Yeah, oh, hang on a sec, I know this is restricted. So I've got to put the positive square root down. Okay, but what would the domain of this new inverse function be? But we know the range of the original function becomes the domain of the inverse function. And if you look at the original graph, we can see that the range of the original function was between 0 and 1, not including 0, but is including 1. Therefore, that becomes the domain of this new inverse function that we've found. Sketch it. I got to admit I cheated here. Oh, look, there it is. Yeah, I just took a screenshot and rotated it. But you should end up with something like that. Okay, so there's a quick little recap of inverse functions, which will allow us on Monday to look at inverse trig functions.